If you step outside, somewhere quiet, and look up at the night sky, you are looking into the past. Every point of light above you, every star, every nebula, it is a story already told, a message that began its journey long before you were born, sometimes before humans even existed. Astronomy, at its heart, is the story of how we learned to listen to those messages, how we turned wonder into understanding. Tonight, we'll drift through that story together. We'll follow the astronomers who first measured the heavens, the light that revealed an expanding universe, the telescopes that peer deeper than eyes can see, and the mysteries still waiting, from UFOs to the dream of life on Mars. Before we dive in, let's take a moment to relax. Close your eyes, settle into a comfortable position, and take a slow, deep breath through your nose. Hold for a moment, and then exhale slowly through your mouth. With each breath, feel yourself sinking deeper into relaxation. Settle in. Let your breath slow. We begin where all astronomy begins, with the simple act of looking up. Long before telescopes, before electricity or engines, people were watching the sky and noticing patterns. The ancient Egyptians built the Great Pyramids so that, on certain nights, its narrow shafts aligned perfectly with the belt of Orion. To them, this constellation was Osiris, god of the afterlife. The heavens were a mirror of the divine. Far across the world, the Maya built stone observations to follow the movement of Venus. They used its bright rise and fall to mark seasons, to plan harvests, and to time their rituals. But it wasn't until the 1500s that astronomy took a radical turn, from spiritual to scientific. A young Italian named Galileo Galilei, restless and curious, built a small tube of glass and metal, a telescope. When he aimed it toward Jupiter, he saw something that changed everything. 4 tiny points of light moving around the planet. Moons. Worlds orbiting another world. That quiet observation was revolutionary. It meant that not everything revolved around Earth, and perhaps not everything revolved around us. From that moment, the universe became a place to measure, not just to worship. We learned to chart its motion, to calculate distances with parallax, the tiny shift in a star's position as Earth orbits the sun. Astronomy became our first great act of precision, our first map of infinity. Light, it turns out, holds secrets. In the 1600s, Isaac Newton passed a beam of sunlight through a prism and discovered that light could be split into color, into information. Every color, every wavelength, tells a story about where it came from. 2 centuries later, a brother and sister in England, William and Caroline Herschel, spent their nights grinding glass and peering into the dark from their garden. They built the largest telescope in the world. One cold night, they spotted a faint, wandering object. At first, they thought it was a comet. It wasn't. They had discovered a new planet, Uranus, the first planet ever found by telescope. The age of discovery had begun. At Harvard in the early 1900s, Henrietta Leavitt studied thousands of star photographs by hand. She noticed something extraordinary. Certain stars pulsed in brightness at regular intervals, and the longer the pulse, the brighter the star truly was. She had found a cosmic yardstick, a way to measure the distance to faraway galaxies. Years later, Edwin Hubble used her data to prove something astonishing. Those galaxies were not just stars in our own sky. They were separate islands of stars, and they were all moving away from us. The universe, it seemed, was expanding. Space itself was stretching. Decades later, a telescope would be named after him, the Hubble Space Telescope, launched in 1990 to orbit high above Earth's atmosphere. Its beginning was rocky. The first images were blurred, a mistake in the mirror's curve. But after a daring repair mission, Hubble's vision sharpened, and the universe opened like never before. It showed us the deep field, a patch of sky no larger than a grain of sand, held at arm's length, filled with thousands of galaxies, each with billions of stars. Proof that even in apparent emptiness, the universe teems with creation. Light, once split by Newton's prism, had become a time machine. In 1964, two engineers in New Jersey, Arno Penzias and Robert Wilson, were testing a radio antenna for Bell Labs. No matter what they did, they heard a faint hiss, a background noise that wouldn't go away. They even cleaned out what they thought was pigeon droppings from the inside of the antenna, but the hiss remained. The static turned out to be the most important sound in the universe, the cosmic microwave background, the leftover radiation from the Big Bang itself. The discovery confirmed what theorists had begun to suspect, that everything, space, time, energy, began from a single, unimaginably hot point and has been expanding and cooling ever since. If you tune a radio perfectly, a small fraction of the static you'd hear right now is the faint afterglow of creation. Astronomy students study this background as a kind of baby photo of the cosmos, a snapshot of when the universe was only 380,000 years old. Even now, the afterglow hums quietly around us, the first light of everything that ever was, still whispering through space. The more we learned, the stranger it became. Einstein's equations predicted that gravity could bend space and time, that stars could collapse under their own weight into points so dense not even light could escape. During World War I, a German physicist named Karl Schwarzschild worked out the math for one of these objects from the trenches of the Eastern Front. He sent his equations to Einstein from the battlefield and then died months later. His idea lived on. We call them black holes. Half a century later, Jocelyn Bell Burnell, a graduate student in England, was studying strange blips of radio noise. They came so regularly, she jokingly labeled them LGM for Little Green Men. But they weren't aliens. They were pulsars, the spinning remnants of exploded stars. Her professor won the Nobel Prize for it. She did not. Still, her discovery opened the door to a new kind of astronomy, one that listened, instead of looked. And then came Vera Rubin, who noticed something odd about galaxies. They were spinning too fast. By Newton's law, they should have torn themselves apart, unless there was unseen mass holding them together. That mass, she realized, was invisible, what we now call dark matter. Later, scientists found something even more mysterious. The universe's expansion was speeding up, as if an invisible pressure, dark energy, was pushing everything apart faster and faster. We don't know what it is. We only know it exists. In the equations, it makes up most of the universe. We, the visible matter, stars, planets, people, make up less than 5%. Time is like a fabric stretched across the universe. When something incredibly massive, like a black hole, sits on that fabric, it stretches and curves it. Objects move differently in that curved space, and time flows at different rates. Near a strong gravitational field, time slows down, compared to places where gravity is weaker. The simplest way to explain it is this. Gravity doesn't just pull on objects. Gravity pulls on time itself. We see a tiny version of this effect every single day. GPS satellites orbiting Earth have to account for time passing ever so slightly faster in orbit than it does on the ground. If engineers didn't correct for that, GPS would drift by kilometers every day. Now scale that up to something unimaginably dense. In the film Interstellar, the crews land on a planet orbiting very close to the supermassive black hole, Gargantua. The gravity there is so strong that 1 hour on the surface equals 7 years on Earth. While the exact ratio is exaggerated for dramatic effect, the underlying physics is legitimate. Near a black hole, gravitational time dilation can become extreme. If you could hover just outside the event horizon without dying somehow, you might experience minutes while entire years pass elsewhere. It's not magic. It's simply the universe treating time as something that can bend, slow, and stretch. What makes this phenomenon so powerful isn't the math. It's the human impact. Imagine leaving home, spending what feels like a few months exploring space, and returning to find that your children have grown older than you. Entire political eras have passed. Cultures, technologies, and even languages might have evolved. When you travel through space, you don't just move through distance. You move through time at a different speed than everyone you left behind. That is one of the most hauntingly beautiful truths of relativity. Wormholes are another major concept, and unlike some sci-fi tropes, they're based on theoretical physics. Think of space as a sheet of paper. Earth is at one end, a distant galaxy on the other. If you travel across the page normally, it takes ages, tens of thousands of years, even at light speed. But if you fold the paper so the 2 points touch, you can create a shortcut. A wormhole is that shortcut, a tunnel connecting two distant points in space-time. Einstein's mathematics allow it. Whether the universe actually uses them is another question. A wormhole doesn't move you faster than light. It simply reduces the distance so dramatically that traveling through it feels instantaneous. It's like replacing a long road trip with a doorway. Here's the tricky part. According to theory, wormholes would collapse instantly unless held open by something exotic, something with negative energy or exotic matter. We've never discovered such a substance in nature, and we don't know if it could exist in the amounts needed. The movie Interstellar handles this accurately. The wormhole the astronauts find is manufactured by higher dimensional intelligence. That's exactly the kind of intervention physicists think would be necessary. Even though we may never build one, wormholes help physicists test the limits of relativity, causality, the shape and topography of space-time, the nature of higher dimensions, and even the possibility of time travel. In fact, a stable wormhole could theoretically allow travel into the past, depending on how the two ends move relative to each other. This doesn't violate relativity, but it does create wild paradoxes scientists still argue about. At the heart of these concepts is a truth that's both scientific and philosophical. We live inside the fabric of space-time, but we only ever experience a tiny slice of it. Your personal experience of time depends on where you are, how fast you're moving, and what kind of gravity surrounds you. The universe doesn't give every traveler the same timeline. When we imagine venturing near black holes or through wormholes, we aren't just imagining exotic locations, we're imagining entirely different relationships with time itself. And that is why astronomy feels so profound. It doesn't just teach us about stars and planets. It teaches us about our place in something much bigger and stranger than we ever expected. In December 2021, another telescope took flight, the James Webb Space Telescope, folded like an origami flower, drifting 1 million miles from Earth. For weeks, humanity held its breath as the golden mirrors slowly unfolded, each segment locking into place in the cold vacuum of space. Webb doesn't see visible light like Hubble does. It sees infrared, the faint heat from the earliest stars and galaxies. It can look back more than 13 billion years, almost to the dawn of time. And what it has seen is astonishing. Galaxies forming earlier than we thought possible, clouds of cosmic dust giving birth to new suns, and the chemical fingerprints of water and carbon in the atmospheres of distant exoplanets. It's not just a telescope. It is a bridge across time, a reminder that even from this small blue planet, we can reach the edge of the observable universe with nothing more than mirrors, math, and a little faith. Of course, not everything we see in the sky fits easily into science. In 1947, near Roswell, New Mexico, a farmer discovered a strange debris scattered across his land. The U.S. military first called it a flying disc, then quickly changed their story. A weather balloon, they said. The legend of the UFO was born. Since then, lights have been spotted, videos analyzed, claims debated in whispers and headlines alike. In recent years, even NASA and the Pentagon have taken an interest, reframing them as UAPs, or unidentified aerial phenomena. Not proof of aliens, but proof that the skies still hold mysteries. Maybe these sightings are secret technology, maybe atmospheric illusions, or maybe, just maybe, we are not alone. The truth is, the search for life beyond Earth isn't fantasy. It's science. Every signal we study, every telescope we launch, is a question whispered into the dark. Are we alone in the universe? We may not know in our lifetimes or ever, but one thing we do know: the desire to move beyond our planet has never been greater. For centuries, Mars has been our celestial neighbor and our mirror. Its red glow in the night sky has inspired myths of war and wonder alike. In 1976, the Viking missions landed on the Martian surface, testing the soil for signs of life. None were found, but the dream persisted. Then came the rovers: Spirit, Opportunity, Curiosity, and Perseverance, each rolling across deserts of rust and stone, searching for traces of water and ancient microbes. They've found dried riverbeds, minerals that form only in water, and carbon compounds, the building blocks of life. Now, scientists and visionaries speak of a new chapter: colonizing Mars. Elon Musk imagines cities beneath its thin orange sky, while others urge caution, reminding us that a lifeless world might still have stories that we shouldn't overwrite. Terraforming Mars, turning it into an Earth-like planet, would take centuries, perhaps millennia. But the idea captures something deeply human: our refusal to stop exploring. Perhaps one day someone will stand on a Martian plain and look up at the pale blue dot in the sky and wonder what Earth looks like tonight. And so, we come back to the quiet act of looking up. Astronomy is not just about stars or data. It is about connection, about the realization that every atom in your body was forged in the heart of a long-dead star, that your breath, your heartbeat, your very thoughts are the dust and light of the cosmos made conscious. As the astronomer Carl Sagan said, "We are a way for the cosmos to know itself." So tonight, when you find yourself under a dark sky, take a moment, look up. Somewhere out there, light is still traveling toward you. A whisper from the beginning of time saying, "You are part of this too." This has been the Restful Record. Thank you for joining me on this quiet exploration of astronomy. Rest well.